Dissociation of PCL5 is an example for reversible reaction. Here PCL5, that is phosphorus pentachloride in gas phase, is in equilibrium with PCl3 and Cl2. Let us write the equation. PCl5 in gas phase is in equilibrium with PCl3 gas plus Cl2 gas. For this dissociation equilibrium, now let us calculate delta Ng value, value of N, that is number of moles, equilibrium concentrations. Let me to write equilibrium like this, equilibrium concentrations and equilibrium constants, namely Kp and Kc. By calculating these values delta Ng, N and equilibrium concentrations, we can derive the value for Kp and Kc, that is equilibrium constants. To calculate this, let us have some assumptions. Initially, we have A moles per liter of PCl5. Initial number of moles is A moles of PCl5, right, like this PCl5, PCl3 and Cl2. Number of moles, that is initial number of moles. Initial number of moles of PCl5 is taken as A moles. Is there initially any PCl3 or Cl2? No, they are products. They will be formed after some time, is it not? So, initially we have A moles. There is no PCl3 or Cl2. So, these are 0 moles. Now, the reaction proceeds and assume that X moles were reacted. So, moles reacted is X moles. Only reactant initially reacts. So, reacted moles is X for PCl5. These are products, they were not reacted yet. So, 0 and 0. Now, this A moles of PCl5 is taken in a vessel of volume V. So, here this X moles of PCl5 reacted to form PCl3 and Cl2. How many moles will be formed by this reaction? According to our equilibrium equation, 1 mole of PCl5 reacts to form 1 mole of PCl3 and 1 mole of Cl2. If X moles were dissociated, X moles of PCl3 will be formed. Similarly, X moles of Cl2, is it not? So, number of moles at equilibrium, number of moles at equilibrium can be calculated as initially A moles, X moles were reacted, remaining will be A minus X moles. Initially there is no PCl3, but X moles were dissociated now to form X moles of PCl3. So, at equilibrium PCl3 will be X moles and chlorine also of X moles. Now, what is equilibrium concentration? Equilibrium concentration. What is this is equilibrium concentration, or it is known as active mass or molar concentration. Active mass or molar concentration. What is active mass? This is number of moles divided by volume in liter, that is molarity, nothing but it is molarity. So, number of moles is A minus X, because this is the number of mole at equilibrium. So, A minus X divided by volume of the container, it is taken as V. So, A minus X by V is the equilibrium concentration. And here number of moles is divided by volume. Number of moles X is divided by volume. So, these are the equilibrium concentrations. So, now we calculated this equilibrium concentrations, is it not? Right. What is N? This is total number of moles. Total number of moles at equilibrium. At equilibrium, what is the number of mole? A minus X. Here X plus X. Add all these values. So, N is equal to A minus X plus X plus X. You can cancel this minus X and plus X. So, N value is equal to A plus X. A plus X. This is the value of N. So, we calculated the value of N. What is delta Ng? It is the difference in number of moles of gaseous products and gaseous reactants. Here, how many moles of gaseous products are there? 1 mole of PCl3 and 1 mole of Cl2. So, total number of moles of gaseous products is 2, which is given by the letter Np. It is given by the letter Np. Np is equal to 2. Number of moles of gaseous reactants. How many reactants? Only 1 mole of reactant. So, number of moles of reactants in the gaseous state is equal to 1. This delta Ng is equal to Np minus Nr, which is equal to 2 minus 1, that is equal to 1. This is the value of delta Ng. Now, let us derive Kc and Kp value using delta Ng, N and equilibrium concentrations. Applying law of mass action, the expression for Kc is given as Kc is equal to active mass of PCl3 into active mass of Cl2, the square bracket indicates active mass, divided by active mass of PCl5. This is the expression for Kc. Now, these are active masses, is it not? So, apply the active masses as we calculated already, that is equilibrium concentration or active mass I told. So, apply this active mass. So, Kc is equal to active mass of PCl3. What is the active mass of PCl3? It is X by V. So, X by V into active mass of Cl2, it is again X by V divided by active mass of PCl5, it is A minus X by V. Now, rearrange this equation, which will give you X into X, that is X square divided by V into V, V square into, put this V in the numerator and A minus X in the denominator because we are multiplying this value. So, V divided by A minus X. Now, the next step you can calculate. V can be cancelled now. So, V square can be cancelled for this V. So, now Kc is equal to X square by A minus X into V. This is the expression for Kc. So, Kc is equal to X square by A minus X into V. Now, let us derive the value for another constant, that is equilibrium constant in terms of partial pressure Kp. You know Kp is related to Kc as Kp equal to Kc into RT the whole power delta Ng. Am I right? You studied this equation already. Now, Kp is equal to Kc into RT power delta Ng. We calculated this delta Ng already as 1. So, delta Ng value is 1. Now, you know the value of Kc, it is given as x square by a minus x into v. You know the value of delta Ng, it is equal to plus 1. So, write this equation as Kp equal to Kc into RT power 1, that is RT. What is the value of RT? For this, you have to consider gas equation, ideal gas equation. You know PV equal to nRT. PV is equal to nRT is the ideal gas equation. PV equal to nRT is the ideal gas equation. We want to calculate the value of RT. So, keep RT here. Bring this n to the left side of the equation, which will give you PV by n. What is n? It is total number of moles. We calculated already as it is A plus X. Total number of moles is calculated as A plus X. So, apply these values in this equation. Kp equal to Kc. What is Kc? Apply the value x square by a minus x into v into RT. What is the value of RT? It is PV by n. So, PV by n. The value of n is A plus x. A plus x. This n is total number of moles. So, at equilibrium. So, now cancel this V and V. This equation will become Kp is equal to x square P divided by A minus x into A plus x. So, this is the value of Kp. So, now we derived the value for Kc and Kp. What is the need to derive all these things? Actually, these equilibrium constant values Kc and Kp will give you whether the reaction is possible or not, to what extent it can proceed. These things are all indicated by these values only. So, this is industrially important equation.